We'll be starting with the session now. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 5C. I'm Dimahi Patel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, New York, USA. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held today in New York, and the virtual event is being held through Zoom today and tomorrow, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for this session. We have with us Isa, Professor Isa Ahmed. Sir is our session chair, and he is a head of control and automation department at Basra Engineering Technical College, Southern Technical University, Iraq. He plays a key role in advancing education and research in control systems and automation technologies. With extensive experience in the field, he is committed to fostering innovation and technical excellence in engineering education and applied research. We welcome you, sir, and I request you to share any opening remarks you may have for the presenters today. Professor Isa Ahmed Abid, sir.
Yes, hi, welcome. Hi, everybody, and welcome in 10th International Conference on ICT for Intelligent System in New York. And I'm very pleasure to be here in the virtual room 5C. So we shall start. Shall we start?
Yes, sir.
Okay.
We also have with us Dr. Geeta Navale as our session chair. Dr. Geeta is currently working as a professor at Head of Department of Computational Engineering in Sihagan Institute of Technology and Science, Pune. She has teaching experience of 25 years and 30 plus international journal publications. She has also been a part of 20 plus international and national conference and has 3 patents. We welcome you, ma'am, and we request to share any few words you may have for us.
Yeah, thank you so much. Yeah, I wish all the participants all the best for this today's conference. And I will be more happy to share the comments at the end of the session. So let's start with the session first.
Thank you, ma'am. We'll be starting with the presentations now. First up, I would like to call Vishnu Kumar, sir, to present his study on a machine learning analysis of behavioral and lifestyle factors affecting heart disease risk in the US using BRFSS dataset. Vishnu, sir?
Hello, I'm trying to share my
Hello.
screen and it's asking me to.
Yes, sir,
Okay,
please
sorry.
try now.
Let's see. Can you see my screen?
Yes, sir.
Okay. Hello,
Yeah, we
everyone.
can.
My name is Vishnu Kumar. I'm from Morgan State University, USA. And today I'm here to present my research titled A Machine Learning Analysis of Behavioral and Lifestyle Features Affecting Heart Disease Risk in the US using BRFSS dataset. So first I'll start with introduction. So heart disease has been a leading cause of death in the US with about 23% of all the total deaths in the US. So as you can see from the picture here, heart disease ranks one of the top leading cause of death according to the American Heart Association, with about 633,000 of total deaths across US in the year 2015. Now, the term heart disease includes coronary artery diseases, heart attacks affecting men, women, all racial, ethnic, and other age groups. So it's kind of a term that encompasses multiple other heart-related issues. So now, Apart from the health-related issues, heart disease also leads to some economic burden, which is about $252 billion with respect to healthcare services, medication, hospitalization, and other expenses. So that being said, heart disease has become one of the healthcare factors that needs a lot of attention. Now, one of the problem with heart disease is sometimes there are no symptoms exhibited until a significant health crisis arises, such as like a heart failure or a heart attack. And there are several lifestyle choices that increase the risk of heart diseases. And some of them include obesity, unhealthy diet, physical inactivity, and excessive alcohol consumption. So being said that these are some of the lifestyle choices that affect the heart disease, so trying to identify some relationship between these lifestyle choices and heart disease might help us build some early intervention and other prevention methodologies that can save the lives of people. So in this regard, there has been a lot of interest among researchers to explore these different use cases. So people have been traditionally using statistical methods for heart disease research. But studies have shown that some of these statistical and qualitative methods have limited accuracy, and they often ignore nonlinear interactions between some of these input variables. With that being said, people in the recent time have now moved over to machine learning techniques. So if you look at the literature, most of the works that talk about heart disease and machine learning often focus on clinical data such as the blood pressure of the patient, the blood sugar level, the electrocardiographic results, the cholesterol level, etc. But most of these features are related to the health-related feature of a particular patient. And the problem with this health-related feature is this data is not often available outside of a non-clinical environment and is often not suitable for proactive screening. So one of the aim of this study is to investigate how modifiable behavioral and lifestyle features influence heart disease risk that are not related to clinical studies such as the blood pressure or blood sugar, but most features that can be modified or changed by some changes in your lifestyle and behavioral aspects of your personal lives. So the research objectives of my study are as follows. So first step is to collect data on some of the behavioral and lifestyle factors, and then train a machine learning model to predict the heart disease risk using this lifestyle and behavioral features, and then identify the most important features, most important input features that affect the heart disease risk. The overall goal is to improve the risk prediction and inform more effective strategies for combating heart disease. So to start with, just showing the data that was used in my study. So my study used the BRFSS data survey, which is the behavioral and risk factor survey that is done in the United States. So essentially, it is a survey that is given to about 400,000 peoples, and the survey has about 40 or so questions. So from that survey results, I'm just extracting 10 features that are pretty much relevant to heart disease and also are some modifiable lifestyle or behavioral features. So these are shown here. So some of the features listed here like health, the mental health days, the checkup time, the sleep hours, smoker status, cigarette usage, BMI, and alcoholism. Some of these are partially modifiable. Some of them are fully modifiable for a particular person. So these are the 10 features that I'm using in the study. And the survey results was obtained for the year 2022. Now, to start with my analysis, I did a correlation analysis to see if there are any input features that are correlated with each other. So if we have features that are highly correlated, then we could drop one of those features because they would have the same information. Now, I set up a threshold of 0.75. So if any feature has a correlation value of more than 0.75, then they will be highly correlated, so they will be dropped. So by using the correlation metrics, I see that none of the features are highly correlated. So I just use all of my 10 input features for my machine learning analysis. Now moving over to the model training. So I used three models for my training purposes, which was XGBoost, Random Forest, and Decision Tree. So this is the selection of these models were based on some of the literature review that I did for this work. Now, I built the model using Python software. The dependent variable is the heart disease risk. The independent variables are the 10 behavioral and lifestyle features that I showed in a couple of slides ago. I use the usual test train split of 80-20. I use the grid search that comes with the cross-validation. Essentially, this is a classification task where we see if a person has a heart disease risk or no. Now, one another factor that I observed was there was a significant class imbalance. So to manage that, I used the synthetic minority oversampling technique or SMOT technique to take care of the class imbalance in my data set. Now, finally, I did some benchmarking to score my model. So using the usual metrics such as accuracy, precision, recall, and F1 score. Now, quickly moving over to the results. So first, I did compare the performance of the 3 machine learning models that I used in my study, which were the XGBoost, random forest, and decision trees. So the table here shows the different metrics such as the accuracy, precision, recall, and F1 score. So among these 3 machine learning models, I found that XGBoost consistently ranked high with respect to all the different matrices, whereas the other models did show some comparatively similar performance, but XGBoost overall seemed to show the best performance. Now, among these 3, I picked XGBoost to do the subsequent studies such as the feature importance. But I just also wanted to show the classification report for the XGBoost model. So as we can see here, the XGBoost model was able to effectively classify both the groups, that is the yes and the no groups, with high precision recall and F1 score for both the classes. Now, once the model was selected, so among the 3, I selected the XGBoost. Then the next step was to go to the feature importance criteria. So for feature importance criteria, I used the SHAP or the Shapley additive explanation values. So the first step was to use the global feature importance for the SHAP values. So the best part of using SHAP is that it gives us the top important features that affected the output. So in my result, the features such as the mental health days, the general health, the BMI, the last checkup time had the highest impact on the output, whereas the features listed in the bottom had the least impact on the output. So this is a global feature importance, which means it takes the entire data set into consideration when identifying the top important features. Now, in addition to the global feature importance, I also performed a local explanation of individual prediction. So this is also another feature that we can do with the SHAP analysis. So we can pick each and every data set in each and every row in our data set and then explain its prediction. So for an example, for a particular example here, a person with a BMI of 19.01 and his last checkup time that is happening within the past 2 years and a general health that is very good. This is what his SHAP value would look like. And again, the features listed in the top, such as the BMI, the checkup time, general health, smoker status, had the highest impact on the output, whereas some of the features listed at the bottom had the lowest impact on the output. Now, this local explanation also shows some color coding, as you can see here. So the blue color shows that it has a negative impact. So which means that having a BMI of 19.01 actually reduced the risk of heart attack, whereas, and at the same time, last checkup time of within the past 2 years also had a negative impact as shown by the negative sign. And the general health of very good also had a negative impact, which means it reduced the risk of heart attack. And then we do have some other features that that increase the heart risk. So this can be done for each and every data that's in our entire data set. So that's one of the benefits of using this local explanation using SHAP. Now, again, I'm going to the discussion. So among the 3 different models that I used, XGBoost seemed to show the highest accuracy, precision, and recall score. So that was selected as the best performing model. And
Excuse me, sir.
Yes.
Gentle reminder that you've crossed your 10-minute mark.
Sure. And then we have the global SHAP value. So the global SHAP value showed the mental health days, general health, BMI, last checkup time has the top contributor. So the benefit of having this global value is it takes the entire data set into account. So it is valuable for public health planning as it identifies a population-wide priorities for interventions. Now, again, we also have this local SHAP value. So it gives the explanation for each and every individual data. So that can help us create some personalized explanation of how you should control some of your behavioral or lifestyle features. Now, finally, just want to talk about some limitations. So this was a self-reported survey, so there could be some potential bias in reporting. And the data set is also only used for the year 2022, so it couldn't actually capture the behavioral changes over time. Now, some future work would actually could explore the use of some longitudinal and clinical data sets and include some other data source such as wearable watches. So we have all our smart watches that can collect some other features like your sleep time, etc. And then you can use some health records, and also collecting data over some diverse population, maybe some adults and kids and school children might also help in some future assessment. So thank you so much for your attention, and I'm open to any questions that you might have.
Very good. Thank you very much.
Issa sir, any questions for him?
Yeah, I have a question, please.
Yes.
Very good presentation. Thank you very much. I just ask a small questions. Can you use support vector machine instead of machine learning?
We could use support vector machines for classifications too, but at least in this work, I just stuck with the tree-based models like XGBoost and decision tree, but we could definitely use SVM.
Okay, thank you very much.
Thank you.
Geeta ma'am, any questions for him?
Vishnu sir. Yeah,
Yes.
am I audible? Yeah.
Yes, I can hear you.
Yeah. Why only XGBoost, random forest, and decision tree? Why not any other model you haven't tried?
So when I checked in the literature, I see that most of the people who used the same heart disease research used some of the tree-based models, but their data was different. They only focused on some health-related data like your blood pressure, cholesterol, and other features that you have to go to a clinic to get the details from. So I just thought, well, why not try to use the same models but instead use some behavioral and lifestyle features that you can change with some maybe exercise or stop smoking or eating more healthier food. So that's one of the reasons. And those models seem to show good performance for their work. So I just thought to explore the tree-based models first.
Okay, thank you so much. Thank you.
Thank you.
Thank you, sir. Now, next, I would like to call AK Delorman. AK,
Yes.
sir, are you here with us? Yes, sir.
Yes,
Please present your paper on accessible eye disease detection using through established image processing techniques.
Yes. Wait a second. I can share my screen. Can you?
Sir, please try again.
Okay. And can you see my
Yes, your
presentation?
screen is visible to us.
Okay. Hello, everyone. My name is Arkay Orman. I will be presenting our eye disease detection project. Wait. First of all, my project definition, this project processes a lightweight classical image processing based diagnostic system for the early detections for major retinal disease, such as diabetic retinopathy, glaucoma, central serous retinopathy, and vessel tortuosity. Unlike a deep learning system that required extensive data sets and high computational resources, the proposed solution leverages optimized classical techniques, including green channel extraction, Clahe, Gaussian blurring, auto-thresholding, and morphological operations to enhance the image clarity, segment the key retinal structures, and facilitate accurate disease marker analysis. Why early detections of retinal disease matters? Because over 16 million people are affected by glaucoma globally, and diabetic retinopathy is leading cause of blindness in diabetics. Central serous retinopathy can cause rapid vision loss, and early diagnosis is critical, preventing irreversible damage. That's why. Sorry. Objectives of study: develop a lightweight system for early detections of DR, glaucoma, CSR, and VT. We use classical image processing techniques to enhance retinal image clarity and segmentation. Detect key disease markers such as microaneurysms, optic cup-to-disc ratio, fluid accumulation, and vessel tortuosity. The ensure system compatibility with mobile devices and low resource environments. Current approach in retinal disease detections, deep learning methods dominate the retinal disease detections, and common techniques include these techniques in CNN, then UNet-based segmentation model, and transfer learning for small data sets. These methods achieve high accuracy but require large annotated datasets, high performance CPUs, and consistent high quality imaging. Limitation of current system and identified technical problems. We have a required and extensive balanced datasets. We have a high dependency on computational power, about, for example, GPU-based systems, sensitive to variations in image quality, lightning, and resolution, poor suitability for mobile or low resource environments, high latency and energy consumption in the real-time processing. Proposed solution overview. These solutions over a lightweight classical image processing system for eye disease detections without requiring large data sets and or powerful GPUs. Designed for mobile and low resource environments, the systems ensures accessibility while maintaining accuracy and providing transparent, explainable workflow suitable for clinical integration. We can talk about system architecture. The system architectures follows a modular approach. Start with fundus image acquisition, followed by pre-processing steps such as resizing, normalization, channel extraction, and noise reduction. Segmentation techniques like Otsu thresholding and morphological operations are then applied to isolate K retinal structures. And finally, disease-specific analyses are performed, producing visual outputs and numerical reports. This modular flow ensures flexibility, transparency, and easy integration into various clinical or mobile platforms. This is my system architecture. We first of all we find a data set, then we do pre-processing steps. We resize, normalize, channel extraction, green, red, blue, for example, Gaussian blurring, Clahe, basing, noise reductions. We're doing that, then including segmentation. When we use auto thresholding and morphological filtering, then we do disease-specific analysis. Then we get results and output at the end. Methodology about vessel tortuosity. The processing begins with resizing the fundus image, ensure uniformity across the samples. The green channel is extracted to enhance blood vessel contrast and highlight fine structure. To improve local visibility, clay is applied and enhancing critical details without applying noise. Gaussian blurring is then used to suppress mesh noise and smooth light inconsistency, so ensuring clean data for segmentation. Background subtraction isolated vascular features, followed by thresholding to produce a binary vessel map. Morphological operations like dilation and erosion refine vessel boundaries. Thinning is applied to reduce vessel width to single pixel. for glaucoma detection, processing begin with converting the fundus image to grayscale and separating green, red, and blue channels. Contrast normalization and custom contrast stretching enhanced optic disc visibility. Then auto thresholding isolated the brightest region as the optic disc, enabling automated segmentation. This preparation was critical for precise analysis of optic structures. Blue channel extraction and histogram normalization highlight the optic cups. Tree-level auto thresholding segmented the background, optic disc, and cup. Morphological operations, for example, array opening, hole filling, refined the segmentation. Ideal ellipses were fitted the optic disc and cup mask, enable accurate cup disc ratio calculation, a critical marker for the glaucoma diagnosis. CSR fundus image were processed using Python and blackout images from optic disc segmentation. Green and blue channels were extracted and normalized to enhance CSR specific features. This highlighted fluid accumulation areas by enhancing brightness difference and applied Gaussian blurring to reduce noise and improve smooths. Perform histogram equalization to further improve visual clarity. Then, after processing the delta, the image was renormalized to ensure clear detection to K region. The brightest pixel and the processed image was identified to mark the CSR region. Future improvements, machine learning integration and datasets diversification for high rootedness. Now, diabetic retinopathy detection fundus image were processed using again Python and blackout images derived from optic disc segmentation. Image were first converted to grayscale, then to highlight intensity feature. Clahe enhanced local contrast, making exudate and order bright region more distinguishable. Gaussian blurring was applied to reduce noise and prepare for more accurate thresholding. Adaptive thresholding dynamically detected bright region indicative of exudates. Combine adaptive and intensity thresholding created robust binary mask. Connected to component analysis measured R and eccentricity, filtering out non-significant or non-circular regions for precise exudate identification. Results are for diabetic retinopathy. Clahe Gaussian blurring and adaptive thresholding were applied and enhance lesion visibility and isolated exudates, resulting in accurately early stage DR detection. About glaucoma, multi-level auto thresholding and morphological processing enabled optic disc and cup segmentation, allowing precise cup to disc ratio calculation for glaucoma assessment.
Excuse me, sir. Gentle
Yes.
reminder that you've crossed your 10-minute mark.
Okay. Central serous retinopathy channel normalization and morphological operations highlighted fluid affected region, enabling effective detection of CSR specific abnormalities. The final one is vessel tortuosity, green channel extraction, segmentation, and vessel thinning allowed curvature analysis, generating a color-coded tortuosity map useful for identifying vascular irregularities. Summary, we used classical image processing techniques to develop a lightweight system to early disease detections. By applying green channel extraction, Gaussian blur, Clahe, and auto thresholding, and we enhanced retinal image clarity. vessel tortuosity was measured through segmentation and tinning enable detection of diabetic and hypertensive indicators. Optic disc and cup were segmented to calculate cup to disc ratio, aiding early glaucoma diagnosis. And final one, the CSR and DR region were detected by isolating fluid and bright lesion using adaptive thresholding and morphological filtering. That is all. Thank you for participating. I can now take a question if you like.
Thank you very much.
Thank you.
Sir,
Okay.
any questions?
I have a question. Yes. Sorry. I have the first question. What do you mean by classical image processing technique? What do you mean by classical image processing
Uh,
technique?
uh, it means, for example,
You have the
Clahe,
name of a classical. Which one? Classical.
uh, deep learning, for example. I can answer like that. Uh,
So your paper as literature. Your paper
yes,
literature review. Literature.
literature. Yes.
So any like what? Like what? Your classical image processing.
Uh,
What do you think? Which one?
Wait a second. I will answer the question. I take my notes. Wait a second.
So what about the data set? How can you collect the data set?
Okay, can you ask me again? Sorry.
It's okay. It's okay.
Okay,
Okay. Okay. Thank you very much.
sorry.
Ma'am, any questions for him?
No, no questions.
Okay, thank you so much, sir, for your presentation.
Thank you. Thank you.
And next, I would like to call Dua Abdul Rahman. Dua, ma'am, are you here with us? I repeat, Dua Abdul Rahman, or are any of the co-authors of this paper present with us? Okay, we'll move to the next one. Kautar, ma'am.
Bonjour. Hello, I'm here.
Yes, ma'am. Please present your paper on blockchain IIoT integration, revolutionizing smart manufacturing process monitoring.
Okay. Can you see my presentation?
Yes, ma'am.
Yeah.
So,
Yes. Okay.
so it's my pleasure to participate in the ICTIS 2025 New York conference and present our work on unlocking secure and efficiency manufacturing blockchain IoT framework for enhancing the process monitoring. This work was written by my colleague Faisal Fadwaki, by myself Dwewi Kautar, and by our colleague Ayub Khadri and our colleague Free Muhsin. Uh, Today, we will explore how blockchain and IoT integration transform smart manufacturing. Our presentation will cover the following section: introduction, research question, literature review, proposed framework, benefit, core pillar of success, challenge and opportunities, and conclusion. Uh, so, Industry 4.0 revolutionized manufacturing by integrating IoT and digital twins technology, enhancing efficiency and connectivity, addressing challenges such as data security and system integration. This paper proposes integration blockchain with IoT to enhance transparency and trust in manufacturing. This strategy aims to overcome persistent barriers, promoting a more secure, efficient, and persistent manufacturing environment and hindering a new area in smart manufacturing. Our research revolves around three questions. How does blockchain and IoT optimize smart manufacturing? What are the main obstacles to their integration? And how do these channels influence the development and adaptive manufacturing prices within Industry 4.0? Our review highlights blockchain evolution from a cryptocurrency foundation to a key industrial platform. It began with blockchain 1.0, focusing on peer-to-peer transaction, evolved through blockchain 2.0 and 3.0 with smart contracts and scalability, improving and advancing the blockchain 4.0 integration with Industry 4.0 technology like IoT and artificial intelligence. The current phase of blockchain 5.0 optimizes the cost, speed, and energy efficiency, supporting advanced industrial application. Our review of literature trust blockchain integration with EOT through five key phases, starting with basic data security and transaction digitalization, advancing to including smart contracts and improving security and transparency, then scaling up with technology like sharding, for free integrating with the Industry 4.0 alongside cybersecurity, IoT, and artificial intelligence. And currently focusing on artificial intelligence driven approach to enhance efficiency and smart manufacturing since with 2021. Our In our proposed framework, blockchain and industrial techno and blockchain and industrial Internet of Things are integrated to enhance process monitoring in manufacturing, addressing inherent challenges in current system. This integration leverages the decentralized nature of blockchain to enhance the data security and create tamper-proof recording through cryptographic measure, ensuring data integrity and transparency. Additionally, EOT devices are employed to facilitate real-time data collection, significantly boosting decision-making and operation efficiency. The model also incorporates smart contracts to automate trust and transaction process, thereby streamlining operation and reducing reliance on intermediaries. This not only improves compatibility with existing setup by using adaptive IoT technology, but also set new benchmark in security, efficiency, and trust within smart manufacturing environment, promising a transformative impact and industrial practice. Integrating integrating blockchain in IoT significantly enhance manufacturing process by offering key benefits across security, operation efficiency, and system flexibility. Blockchain's decentralized nature not only bolsters security and build trust by minimizing risk and centralizing point by its cryptographic mechanism, also ensure that recorders are tamper-proof, thereby improving data integrity. Real-time data collection enabled by IoT device enhance decision-making, while their compatibility with existing system adds flexibility. Additionally, smart contracts automate transactions, increasing both efficiency and reliability. Together, this technology set not only standard in smart manufacturing, creating a more secure, efficient, and transparent production environment. To secure the success of blockchain and IoT integration in smart manufacturing, it relies on four key pillars: decentralization, which prevents only single, which prevents any single point of failure by speed and control across network; security, ensured by tamper-proof recorders that maintain data integrity; real-time transparency, which provides immediate data access to all stakeholders for an enhanced collaboration; and traceability, allowing every data point to the traced back to its origin, essential for efficient process monitoring and compliance. Integration, blockchain, and IoT in process monitoring face challenges like standardization protocol, adoption, the regulation, ensuring scalability, managing cost, and recent skills shortage. However, this challenge presents opportunities to enhance cybersecurity, develop specialized smart contacts, fostering collaboration, integration, edge computing for real-time analytics, and continue research. Addressing this can lead to a robust framework that improves security, efficiency, and innovation. In conclusion, blockchain and IoT integration in manufacturing process monitoring offer transformative benefits. Our model ensure use blockchain, decentralization, nature, cryptography, secure and smart contact with IoT device to enhance security, transparency, and efficiency. Taking a challenge like data security, and scalability, we aim to revolutionize manufacturing, setting a promising path for future development in smart manufacturing. Thank you for your attention, and I'm now ready to take any question you
Thank
might
you
have.
very much. Thank you very much.
Ma'am, any questions for her?
No, no.
I have very small question.
Yes, please.
Yes,
So,
sir.
so do you use any AI algorithms
In this
you
paper,
use
no,
in your
but
in your work? Yes. In your work, yes. But in this paper, not.
yes, in our future work, we work in artificial intelligence algorithm that we aim to concurrently to use it in practice with integration with IoT and blockchain.
Uh-huh. Thank you very much. Okay. Great.
Thank you, ma'am.
Thank you.
Next, I would like to call Lorenzo Rigatti to present his study on DLT Bond Platform, a decentralized blockchain protocol for wholesale settlement of digital bonds.
Hello, everyone. Nice to meet you all. It's a pleasure to be here.
Bye.
Okay, you should be able to see the screen.
Yes, sir.
Perfect.
Yeah. Yeah.
So, thanks for having us. What we're going to discuss right now is DLT Bond Platform. It's the result of a year of hard work on a decentralized blockchain protocol for wholesale settlement of digital bonds. So just to start, I would like to thank the fellow colleague I shared this path with, Fabrizio Venettoni, Davide Paglia, Andrea Sabatini. So really thank to really contribute for this success. To give you more context of what we are discussing in a while, we are describing and talking about the tokenization market. We will analyze the context and the problem that we have nowadays with a specific focus on the debt market. So we will not embrace the word tokenization phenomena, but just the debt market. The solution we proposed, analyzing what is missing, so what's new in our DLT bond platform, which has a new model, a new technical framework that will be described at the end. So first of all, what we have identified working together with financial institution is, particularly nowadays, I would say in a complex market ecosystem, ensuring a better access to capital is a key challenge to bridge the gap between the finance world and the real economy. So tokenizing is not just something that it's needed from a technical perspective to improve something, but it's a real business need, it's really social need, I would say, to reach what we would like to reach since like 20 years probably from now, which is a real capital market union based on infrastructure, based on cutting information asymmetries. So link the word also from a financial infrastructure, as we have right now, thanks to the internet. However, we have identified some problems because even if the tokenization nowadays is gaining a lot of momentum, but there are still lack in the market. So first of all, if you tokenize something and it's doable, it can be done. We see some use cases. If you use a cash leg which is not on chain, you don't have an atomic swap. So it's a risk that needs to be priced. If you have instead a stable coin, so the cash on chain, and so you potentially have an atomic swap, what you got, you have a counterparty cash risk. And again, you need to price it because we are not talking about yet central bank money. You have many regulations. So again, achieve a capital market unit is not just a matter of technical improvement, but also this improvement needs to be adapted and followed by a common regulation. This fragmented market is basically producing a lack of liquidity. So many tokenized assets are still illiquid. And also because there are different standards. So what we will, explain today is that we are betting on a public blockchain because for us it's a standard. The Ethereum language is a standard, can be used worldwide, let's say with the same effort. Moreover, we will face also some security challenges because going on chain as a plus, but also something that needs to be addressed, particularly because you have potentially sensible data that now are public. Completely rely on internet, and moreover, you need to convince financial institution to use a totally different infrastructure. So our paper and project pillars are a lot, but basically to squeeze in a few minutes are three. So first of all, the compliance. Okay, even if it's tech paper, but our main commitment was to compliance is the day first. So be aligned with the EU regulatory framework to produce something which was not just a test, because in our case was a real operation, was a trial in the ACB phase last year, and to produce something that was scalable and replicable. Second things, T+0. So we now, are experiencing T+2, target 2 system. So the project goal was to reach T+0. So, and particularly the perform the delivery versus payment in seconds. And these settlements, considering the risk, particularly the counterparty risk I just highlighted, in our mind, the only way to make it happen was to use a central bank currency. So no counterparty risk guaranteed by the European Central Bank. So these were the pillars. The solution, so to briefly describe the main component of the solution were two. So the block invest solution, which is a proprietary smart contract solution developed by the company that I had the privilege to found it 5 years ago, which is EVM chain. In this case, we developed and deployed on Polygon post chain. And the wholesale settlement solution made available by the ECB, particularly through the TIPS link solution developed by the Bank of Italy. So the work combined by the block invest solution and the API gateway developed by the Bank of Italy was the smart way, I will say, that made possible to link the asset leg on a complete decentralized blockchain like Polygon POS and wholesale central bank currency on target system, again in T+0. So what's new? First of all, we invest a lot of time and resources with all the stakeholders on the processes. So we developed a new technical and operational model, which was a combination of Web 2, so off-chain data, and Web 3 components that were made possible to make this DVP in central bank money, again in T+0. So what we did, considering also the novelty of the solution, was to design and develop an end-to-end solution. So we developed the first service capable of carrying out all the phases. So not just create the token, but manage the whole value chain. Second, again, use a public chain, permissioned, permissionless ledger, but permissioned framework, because our goal was to exploit the blockchain, but to assure in the same time the institutional player that usually prefer the private network to provide the same level of segregation that you have a legacy system, segregation of the different roles involved in the whole issuance life cycle. Last but not least, also work on the disaster recovery and business continuity provision. So apply all the necessary actions and develop all the control check that made sure that if something happened, we were ready to eventually make some transition on a new ledger. So this project had some validation. Again, we start always from the regulatory point of view. So the first validation was from the regulator. Again, this was a real market operation. So we went through the assessment of the specifically Italian authority for the supervision of financial markets, so the concept. Second validation was the ECB. So they allowed us to, exploit the wholesale settlement service to, again, through Bank of Italy, exploit the settlement central bank money. Last but not least, the validation from the market. So thanks to the biggest Italian bank in São Paulo, the process was completed in a real issuance. So real market operations carried out last year in July and completed in November. So how we did that? Through several steps. Again, I would like to underline and stress the fact that was not just the creation of a financial instrument, which is not easy, but it's doable. But what we did is manage the whole value chain from cradle to grave. So starting from the onboarding, setting up the environment, deploy the factory smart contract, setting up the users, different kind of users with different permission. All the, access control were guaranteed through blockchain transactions. So who can act on chain on behalf of the organization was written and managed on chain. Second step, for sure, the issuance. So fully automated process again, integrated with the cash system with TIPS link solution. The process was instantaneous, was simultaneous, and through the platform we're able also to create and structure the financial instrument details, like duration, like coupon, like eventually all the covenant that were attached to that financial instrument. Last but not least, also the redemption was managed through the DLT bond platform. So at maturity, the bond became inactive, so marked as expired on chain. The platform and the solution ensure that the investor can exercise his right to receive, if any, the coupon payment and the principal amount at expiration, again in wholesale central bank digital currency. So I'll go very
Excuse
brief
me,
on
sir.
that. Yeah,
Gentle reminder that you've crossed your 10-minute mark.
absolutely. So let me just finish with that. I'll leave you the stage for the question. Our commitment are really straight. So we would like to foster the adoption, inviting and included other financial institutions in our domestic market, expand other financial assets, so working on mini bonds, certificates, commercial paper, and other financial instrument that the market would require, but mainly expand abroad to, work together with other, starting from other European countries like France or Germany, to achieve together our ultimate goal, which is build a solid capital market union. Yeah, thanks for the attention.
Thank you very much. Thank you. Good.
Any questions, sir?
I don't have any question. Thank you very much.
Ma'am, any questions for him?
Yeah. Do you face any challenges related to scalability?
Yeah, thanks for the question. Actually, it's not because the bot component that we use to manage the operation, the deep scheduling solution, and also the Polygon chain are really scalable. So the throughput of the two network are, I would say, impressive. And that's why we decided to invest a little bit more time to create something that was able to scale. Because checking the numbers, potentially you can make a lot of transaction. Think about it now, this kind of settlement are done in T+2. So we did it in second. So this scalability potentially is absolutely interesting. So no issue in that. We see that there are opportunities in the scalability that we saw. So that's why we're really optimistic. I don't know if I replied to your question.
Yeah. Thank you.
You're welcome.
Okay, thank you, sir.
It was a pleasure.
Now, next, I would like to call Dua Abdul Rahman. Dua Abdul Rahman, can you hear me?
Yes, I hear you.
Yes, sir. I've been told I have to present your PPT. Is that right?
Yes.
Yes, sir. So please let me know when to change slides and I'll be changing them for you.
Okay, thank you.
Please start the presentation, sir.
Okay. So, good day, everybody. Today, I will be presenting an overview of Bitcoin, the first decentralized cryptocurrency. Bitcoin enabled secure and peer-to-peer transaction without any need for anything else but solo cryptographic algorithm. Please, can you change the slide? You know that current trust systems usually use centralized certificate authority that exchange keys and enable the trust between the two parts of the communication, the sender and the receiver. But when you need to rely on a peer-to-peer or distributed network that has no observer, you might need to have a kind of anonymity or trust with the other party of the communications. by relying on cryptographic protocols like zero knowledge protocols or uh, what we need now currently as a distributed ledger known as blockchain. So blockchain exists before Bitcoin, long time ago, before Bitcoin. But the phenomena for blockchain came with the existence or the appearance of Bitcoin. Please, can you change the slide? Bitcoin was introduced in 2009 by pseudonym Satoshi Nakamoto. It was designed as a reaction to the failures of centralized finance systems, aiming to provide a transparent and permissionless and censorship resistance form of money. Of course, in the case of misuse of technology, we need to enforce the law and the law order of the society and the community, and it might need to be adapted by governments in order to achieve such kind of needs. Can you change the slide? Next slide, please. Uh, at its core, Bitcoin operates on blockchain, as we said, blockchain technology. This decentralized ledger records every transaction securely, ensuring transparency and immutability. Each transaction is verified through cryptographic signatures, digital signature schemes, and of course using hashing in order to achieve the authenticity and the integrity of the blocks, maintaining trust across the network. Next slide, please. Bitcoin uses a peer-to-peer architecture, meaning each participant acts both as a client and a server at the same time. Instead of having a centralized server and all of us will be a client, each party of the communication, each participant will play the two roles, client and the server, in the time of sending or receiving. This design reduces single point of failures, but introduces vulnerabilities such as distributed denial of service and cyber attacks. Distributed denial of service attacks, if you trying to send huge amount of traffic or very big payloads to the recipients, and then you utilize the resources, the computational resources, and the communication links with fake traffic. If instead of making use of the existing vulnerability of the designated target, you just send the traffic that will utilize the resources. And of course, the block of the service for other legitimate users will happen. And this is the backdraw or the shortcome of using such kind of technologies. Next slide, please. Transactions in Bitcoin are based upon public key cryptography. In public key cryptography, we have a two different pair of keys, public and private keys, for each participant. And the signer will use a private key to sign a message, and the recipient will use the public key of the sender to verify the authenticity of the message. Every transaction consumes unspent transaction outputs as an input and must be digitally signed, as we said before, by the owner of the message or the block to be validated by the recipients. This design prevents forgery and ensures authenticity of the traffic. The next slide, please. Proof of work, this is a concept in blockchain and Bitcoins. To secure the network, Bitcoin uses a proof of work consensus algorithm. Miners compute to solve cryptographic puzzle, and the first to do so adds a new block to the blockchains. This process not only validates the transactions but also prevent double spending. Instead of using the same block or like number again, this is what we call double spending. Next slide, please. Each mine block is added to the blockchain, creating a chronological tamper resistance record. In the case of network force, the chain with the most accumulated proof of work, the longest chain, is considered the valid one. Next slide, please. Bitcoin's security model relies on the assumption that the majority of the computing power is honest. And to ensure this, miners receive block rewards in Bitcoin and transactions fees. Mining pools aggregate resources to improve chances of earning rewards. Next slide, please. In conclusion, Bitcoin remains a groundbreaking innovation in digital finance. However, challenges persist, particularly around scalability, energy efficiency, because mining consumes a lot of power, and privacy, of course, one of the major issues. And from the government perspective will be how to enforce the law of order. And this is my presentation. Another thing for the future work, we need to work on deployments. Many to involve layer 2 technologies, advanced smart contracts, and alternative consensus mechanisms, in order to balance between the privacy that blockchain and Bitcoins provide and the security that's needed by the organization or central banks worldwide. Thank you.
Thank you very much.
Sir, any questions for him?
Yeah, I have a question. Is the
Please.
Bitcoin? Yes, thank you. Is the Bitcoin depend totally on the blockchain? Depends totally on the blockchain?
The major component is blockchain, but there is a different components such as a smart contract, one of and proof of works. Proof of works, not a blockchain. So different components, but blockchain concept exists maybe 30 years before the existence of Bitcoin. But Bitcoin is the example that brought blockchain to reality, if I can say it.
I see. I see. Okay, very good. Thank you very much.
You're welcome.
Ma'am, any questions for him?
No, no questions.
Thank you.
Okay, thank
Thanks
you
for your
so
time.
much, Zubair.
Thank you. Take care. Bye.
Now, next, I would like to call Meera Kuntz. Meera, ma'am, please present your paper on optimized meta scheduling in Galaxy using TPV broker.
Hello. Zoom says I cannot share. Now I can share, yes. So I'm presenting to you the project Optimized Meta Scheduling in Galaxy using TPV Broker. And first, what is Galaxy? Galaxy is a platform for data analysis. It's free and open source. It comes with many tools and is quite popular in science and has a large user base. The topics cover not only bioinformatics, but also chemistry, ecology, and other disciplines. Galaxy covers the whole research data management lifecycle. So from planning your research, collecting data, analyzing it, and sharing it. And we have many jobs, but also many cooperation partners from various projects. so we can distribute our jobs across Europe. And this happens with a service called Pulsar. It's a small Python application that is deployed on the compute endpoints, and Galaxy can use it to run jobs there. It fetches the data from Galaxy, resolves the job's dependencies, and uses an existing local scheduler, such as Kubernetes or Slurm, to run the job. With all these different compute resources, Galaxy needs a piece of software that combines everything together and keeps an overview of all the connected entities, just like the Total Perspective Vortex in the Hitchhiker's Guide to Galaxy. But it's a Python framework designed to dynamically schedule millions of jobs, and it's configurable via Galaxy using specific rules in YAML syntax. TPV can access extensive metadata, including user objects, provenance information, data locality, size, etc. And it distributes jobs to resources such as Arc or Pulsar and makes intelligent, dynamic decisions for optimal job routing. To better understand why we came up with TPV Broker, I would like to explain the basic concepts of TPV. TPV can handle different entities such as users, roles, tools, and destinations. Each entity can have different resource requirements and other parameters, which we'll leave out for now. TPV's task is to combine these and determine a viable destination for the job. TPV supports custom ranked functions implemented in Python and enable advanced meta-scheduling by querying an API endpoint and selecting the optimal destination from a list, defaulting to the most preferred option if no custom function is provided. So the current state of the system is that Galaxy uses the Total Perspective Vortex for scheduling, but the limitations of TPV is the lack of real-time awareness of the system status, and it's a centralized approach that struggles with scalability in large environments. And the goal is to integrate real-time feedback to enhance scheduling decisions. And these challenges highlight the need for a smarter data-driven coordination across TPV. And that's exactly why we developed TPV Broker. The TPV Broker enhances TPV by introducing three major capabilities. First, it enables real-time collection of resource metrics from all participating sites, which gives us an up-to-date view of system availability and load. Second, it improves queue and data locality management, so we are not just considering raw capacity, but also where the data actually lives and how jobs are queued. And third, it enables dynamic data-aware job routing, meaning jobs are steered to the most appropriate destination based on current conditions and data placement. TPV Broker uses a producer-consumer model to track and update resource metrics continuously. And with Galaxy Job Radar, we can visualize workflow. So in this diagram, you can see on the left side the users that start their jobs through Galaxy, just like they would do normally. And behind the scenes, Galaxy uses TPV, which compares the job's requirements with the configured destinations. TPV sends the job's details, like how many cores and how much memory they need, along with where the data is stored, to the meta scheduler. The meta scheduler looks up current system metrics in InfluxDB, a time series database, to decide which remote site is best fit, factoring in things like current workload and physical distance. Metrics are centrally collected by Telegraph at the endpoints, sent to RabbitMQ, consumed by Telegraph again, and stored in InfluxDB. These metrics are then used by two key components, the meta scheduler and the job radar. An important aspect of the setup is that neither the Pulsar endpoints nor Galaxy need direct access to InfluxDB. They only require credentials for the designated RabbitMQ virtual host. To deal with this complex and constantly changing environment, we decided a fuzzy matchmaking algorithm for the meta scheduler. This algorithm uses fuzzy logic to match job requirements like CPU and memory with the available resources at different endpoints. Unlike strict matching, fuzzy logic allows us to evaluate degrees of compatibility, not just yes or no. The process has three main steps. Fuzzification. This converts concrete job and resource data into fuzzy categories. For example, a job might be labeled as requiring high memory rather than a fixed value. Second, rule-based decision-making. We apply a set of fuzzy rules to determine how well a job matches a given resource. And third, defuzzification, we turn the fuzzy output into a crisp score, which we can use to rank and allocate resources. And this method has two big advantages. First, it adds flexibility in handling different levels of compatibility, which is useful in heterogeneous environments. And second, it adapts dynamically to real-time resource conditions, improving scheduling decisions as the system evolves. The first step in the fuzzy matchmaking process is the fuzzification. Here we take raw numerical data like CPU cores, memory, or resource availability and translate it into fuzzy sets such as low, medium, or high. This allows us to handle uncertainty and partial matches more gracefully. Let's look at a simple example. If a job requests 8 CPU cores, we might classify that as medium. If resource has 6 cores available, we could label that as low. By mapping these continuous values into fuzzy categories, we can express compatibility in more flexible terms. This is essential in real-world environments where perfect matches are rare and resources vary constantly. So here you can see the functions schematically that map the continuous values to the fuzzy sets. And let's look at an example how the fuzzy rules work. This is a very basic example. If the CPU slot size of the given job is allocatable in the available CPU slots on the resource, and the memory image of the job is allocatable in the resource available memory, then the resource is considered a compatible match for the job. These rules let us evaluate not just whether a resource can technically handle a job, but also how well it matches. And using histograms from InfluxDB, the algorithm can calculate a queue matching factor, which is based on the median queue time and the current queue size, and a compute matching factor, taking into account the median runtime and the number of currently running jobs. With these factors, we can represent how long the queue is and how high the compute load is. The bigger the number, the better. So you can keep in mind the queue matching factor and the compute matching factor. And now we can combine both factors using a simple addition, and we get a total matching score, which reflects the endpoint suitability for job allocation. And now we have applied our logic and calculated fuzzy. We need a crisp value, which we can use to make a clear decision and report the best match back to TPV. This is where we take all the fuzzy evaluations we have gathered and convert them into a single concrete number, a crisp match score. This score tells us how suitable a particular resource is for a given job. And we can sort now the endpoints based on their distance to data and then on their match scores. This way we can break potential ties from the match scores. When TPV gets this list of endpoints, it chooses the first endpoint, which has the best resources, meaning a combination of short queue and low load. Now we come to the other part of TPV Broker, the job radar. It is a tool to visualize the job flow as well as the resource utilization on the endpoints, and so enables administrators to monitor the job flow and detect potential anomalies. You can try our official instance by scanning the QR code and see the current job flow of the European Galaxy server. Here is a screenshot, and you see, for example, as green, the running jobs, and in yellow color, the queued jobs. Now let's wrap up by looking at the...
Sorry for interrupting, but this is a gentle reminder that you've crossed your 10-minute mark.
Thank you. Now let's wrap up by looking at the key benefits of TPV Broker. First, it significantly improves scheduling efficiency. Thanks to real-time resource tracking, jobs can be allocated more intelligently, closer to where the data is and resources that are actually available and have a low load. This reduces unnecessary data movement and helps make better use of existing infrastructure. Second, the TPV Broker adds scalability and fault tolerance and acts as a smart coordination layer that scales easily across multiple endpoints. And finally, TPV helps promote energy-efficient computing. By directing jobs to underutilized nodes, we not only balance load, but also reduce overall energy footprint of our workflows. So in short, TPV makes Galaxy smarter, faster, and more sustainable. And looking ahead, there are several exciting directions for future development. Make the scheduling more energy efficient by considering live electricity provider data and predictions. And there's also strong potential for machine learning integration using historical workload data to enable predictive, even more efficient job scheduling. Finally, we aim to expand the Galaxy Job Radar with historical analysis and performance metrics. I want to thank all the other authors of our paper Optimized Meta Scheduling in Galaxy using TPV Broker. And I want also to thank our partners and funding partners, and I want to thank you for your attention.
Thank you very much.
Sir, any questions?
Yeah, I have a question. As I see, you use for optimization fuzzy matchmaking algorithm, yes? Fuzzy algorithm.
Yes.
So why don't you use like another algorithms like genetic algorithm, particle swarm instead of fuzzy? Because the fuzzy is like more complicated than the others algorithm, the other optimization algorithms.
Yes, I think the fuzzy algorithm enables us to
And it is
have like
the
partial.
fuzzy, it is algorithm fuzzy. It is
Yes, it is
algorithm or system.
It is a fuzzy algorithm. So we have first the conversion, the translation of the continuous values into fuzzy sets, and then we apply specific rules that capture expert knowledge. Such, for example, if there's a specific amount of memory on the nodes, and the requested memory is higher, we could still consider that in some cases a partial match. And I think this is where we use a fuzzy algorithm.
So do you think we can use, for example, genetic algorithm or cannot?
Genetic? Sorry.
Yeah.
I think in our case, it would make sense to stick to the fuzzy algorithm, because then we have the different sets there and we can apply our logic.
Yes. Good. Okay. Abdulrahman.
Yeah, so my name is Abdurrahman. I'm from the group who wrote the paper. So I actually designed this fuzzy algorithm. So the idea is how to establish the fuzzy membership function.
So it is from your design.
Yes.
Okay, good.
Yes. So the idea for fuzzy logic, from the name, it is fuzzy. It means that it is not something that is very specific, and this is the difference between the main difference between the regular schedulers that compares very specific information and the fuzzy logic. You get the most suitable endpoint based on this fuzzy membership function. So the best thing to do is to make the fuzzy membership function established to be realistic enough, so that when you get the intersection with the input membership function, it is close to reality, and it can give you actually the best result for the best resource for this job. About genetic algorithm, it is a different approach. Also for neural types of or training for models. This is something that we are working on right now to bring a model and to train this model based on the for this type of tool, what is the suitable resource and how this suitable resource should be. These are two other types of like smart scheduling, but for the fuzzy one, you get the input membership function for memory and for CPU for each of the endpoints and try to make it as matching as possible to the actual condition. And the current input membership function, it is a histogram for the number of nodes, the current number of nodes, for example, with the CPU, number of free CPU cores between 10 and 20, how many of these? Between 20 and 40, how many of these? And the same for memory, for those who have like 8 gigabytes of memory free now, how many of these? Between 8 and 16, between 16 and for example, 24. So this is how the input membership function is shaped.
I see. I see. Thank you very much. It is very good explanation. So thank you.
Ma'am, do you have any questions?
Yeah. Am I audible?
Yes, ma'am.
Yes.
Yes. How can a TPV broker ensure privacy preserving data sharing between users and verifiers?
So TPV broker actually does not move the data. The data is moved by the Pulsar network. So you can imagine Pulsar as a script that runs on an endpoint. Maybe I can show the slide again. You can see it. No, it's here. So we have this network. The Pulsar endpoints then fetch the data from the European Central Galaxy Server, and they use SSL encryption. So the data is completely encrypted while being moved to the compute endpoints.
Thank you.
Does this answer your question?
Yes, thank you.
Okay, thank you so much, Meera and Abdul Rahman.
Thank you.
Now, next, I would like to call Vasil Svetkov to present their study on parametric analysis of a collaborative robotic mobile platform for healthcare application.
Hello, everyone. Thank you for the given opportunity. I'll now try to share the presentation. Is it good now?
Yes, sir.
Yeah, it's clear.
Hello, everyone. My name is Vasil Tsvetkov, and together with Associate Professor Nina Vochkova from the Bulgarian Academy of Sciences, we're glad to present you our latest research titled Parametric Analysis of a Collaborative Robotic Mobile Platform for Healthcare Application. I will start with a little historical background. The first robot in industrial application was installed by General Motors in a plant in Trenton, New Jersey in the late 50s. It was so successful that a couple of years later, around 450 to 500 Unimate robotic arms had also been deployed in the industry. Well, one noteworthy aspect of that is that until recent, potential safety hazards for humans required most industrial robots to be isolated with protective enclosure in order to safeguard people from the robot and its actions. Then 2004 came when a major shift occurred when KUKA Division Industries introduced the first commercial cobot. Well, with the involvement of the cook robot, that eliminated the need for barriers around the working area of the robot. This paper investigates the dynamic characteristics of one such collaborative robotic mobile platform with enhanced manipulability. Its motion parameters, such as linear velocities and accelerations, and their influence on platform control are analyzed. The experiments performed include monitoring acceleration processes, constant lateral movement, and deceleration and braking phases. The presented graphical analysis demonstrate key features to the platform dynamics that can be used to optimize and control of one such mobile platform. Current challenges in robotics, well, today they face several challenges, with the most critical being the ability to operate safely, as I already stated, and efficiently alongside humans. As robots move from isolated industrial roles to collaborative healthcare environments, enhanced environmental perception and responsive motion control have become essential. So, to achieve this, we must evaluate the manipulation system of the robot by its parameters in an accurate manner. So, we use and differentiate among two main approaches doing that. The first one, called direct computational, it is a computational based approach. So the procedure is final and straightforward. The second one, it relies on an embedded model and it is called iterative. In the iterative approach of parameters evaluation, the proximity between the estimate and the examined parameter is achieved using an adaptive self-adjustment, that particular model. So once the device controlling the experiments evaluates the corresponding parameter, the next stage, which is calibration, follows. The calibration itself involves aligning the parameters in the model as closely as possible with the actual parameter of the robot, thus ensuring enhanced manipulability. Both of those methods help identify and calibrate the dynamic parameters such as force, velocity, as in our case and in our studies, and acceleration, and improving, of course, the robot's real-time response. So this is the diagram of the parametric analysis of the manipulation system of a robot. Here we present the methodology for our analysis. We treat the robot as a dynamic system, which system is a combination of modeling and state observation. This allows us to estimate unmeasured variables using a Leuenberger observer, which is robust to disturbances and in our case ideal for real-world environments. So the stages of calibrating an industrial robot are as follows. First, we have to determine the model operator to achieve the set goal, carry out a precise measurement of the parameters being studied using appropriate equipment to do that, and calibration of the studied parameter after the identification phase. So the accuracy of the identification process depends on the number of measured points and the type of the placement of the measurement equipment. In order to effectively identify all the characteristics of the actuator mechanism of the robot, such as an industrial one, used for the assembly, parameters that characterize not only the target movement, but also some of its specific features should be defined. And here we can see the diagram that we present, and this is a diagram of the main functional parameters that have been set in our methodology. And these parameters follow a logical sequence of development or dependence between them. So starting with the reachability referring to the serviceable space, serviceable zone. And this is the area in which the robot can reach and work. The range of action and the ability to cover the workspace depend on it. Next, mobility. Here we refer to speed, the speed of the platform. Mobility is a key factor for time efficiency, actually. So especially in dynamic environments, higher speed improves productivity, but that brings some of, how to say, some negative aspects, for instance, in terms of positioning accuracy and stating positioning accuracy. That is the accuracy of positioning and, of course, orientation. They're essentially both very similar. That determines how precisely the robot can perform tasks, especially in the manipulations. Repeatability. Repeatability is important for tasks that require consistency and reliability in repeatable operations. And finally, we have the load capacity. Load capacity determines how much the robot can carry, which is important in transport or assistance application, as in our case, we are dealing with application in healthcare. So this diagram shortly can be used to illustrate the process of selection or evaluation of robotic system according to the requirements of a specific application. So we move on to the measurement methodology. Measurement methodology relies on set of measurements taken in an time intervals of 100 milliseconds. We have installed a inertial measurement IMU module that provides data on linear accelerations among the three axes. So the key variables examined in the experiments are as follow. We have the linear velocity, both on X and Y axis, linear accelerations, and we fill the data in a table. So from the obtained data, we can then draw the graphs, the sensor data graphs. This that we see now, this is the movement along axis. We have velocities and accelerations plotted together in respect to time. In our case, the experiment was carried for a 5-second interval. And here we can distinguish clearly three phases: initial phase, acceleration, and braking of the platform. Now we have the we can move to plotting multiple variables with respect to time. We have the angular speed and the torque of the driving motors of the platform. And again, we can see the three distinct areas, starting with the high torque. This is the initial moments. This is when the platform starts moving. Then we have settled speed, and we have the braking region at the end. So talking
Sorry
about...
for interruption, sir, but this is gentle
Yeah.
reminder that you've crossed your 10-minute mark.
Thank you, thank you. Talking about the movement of the platform, we have implemented a PID controller. Here we can see the responses of the PID controller and how it tries to set the speed to the reference one, to this desired one. I will quickly move then to the methods of setting up the PIT controller. We used Ziegler-Nichols, and here we can see brief instructions on how the setting was made. Now, regarding the observation of the movement of the platform, we didn't see any overshooting, any disturbances, and in generally the platform behaved very well with the initial setting of the parameters by Ziegler-Nichols method. This is the topology that we have chosen for our collaborative robot. It is layered modular topology in order to meet the criteria for mechanical design. And this is the control structure. It is based on master-slave topology. We use actually 2 Raspberry Pis. One is used as a slave controller. One carries out the control of the platform and runs the robotic operating system on it. And in conclusion, we can see that we validated our mobile platform through structured sensor experiments. We did parametric analysis and real-time feedback, thus enhancing the trajectory control and repeatability. And ultimately, our system offers reliable, repeatable, and safe performance, which is critical for healthcare application. And this experiment was part of another bigger project that I would like to acknowledge. And thank you very much for your attention. If you have any questions, I'd be happy to answer.
Thank you very much. Thank you.
Sir, any questions?
Yeah, I have. Thank you very much. The first thing I understand from the title of your paper, you use a collaborative robotic mobile. You mean there is more than one mobile robot? Yes?
No. Actually, sir, we developed that platform in order to do testing in real world scenarios. Actually, we deal with kids with mental conditions, so to say, and we use these robots in order to interact with them. For instance, on that platform, we can couple various sensors, we can couple human-machine interface, and thus making it appealing for children to interact with one such machine. I don't know if I can explain myself.
So your platform, it is practically used? Practically
Absolutely,
you done?
yes.
So another question, please. You used BID controller.
Yes, correct.
How you select the parameters of BID controller, because you have KB, KI, KD, 3 parameters.
Yes. First, we began by setting the PIT controller to a pure proportional controller, and we this is based on my experience, actually. At the university, I graduated with the automation. So I pretty much know what to expect from one such configuration, and I set initial parameters, then observed
it is
how...
It is like to be try and error?
Try and error, yes. It is some kind of an iterative approach.
I see.
So Ziegler-Nichols basically has 2, how to say, I don't know the word, 2 ways to set a PID controller.
Yeah.
Yes, you know.
Ways, because you have to you have to take time to set the parameters.
Yes, but short answer is I just know in my mind what to expect from one such configuration of a robot. So I started with I don't know, in my mind I knew what to put, and of course the movement was not what was not that smooth. There was a little bit of overshooting. So with a little bit of trial and error, we managed to meet the requirements for our application.
Okay, I see. Thank you very much.
Of course,
Very
there are
good.
other approaches, there are other more precise approaches when tuning a PID controller.
Yeah, because maybe when we use another algorithm to set the PID controllers, the parameters, maybe will be more correct or more precise. If you use another algorithms like to be optimization algorithms to set the parameters of PID, I think will be more accurate.
Yeah, of course, not to mention I believe it was the Cohen method. It is far more precise than Sigler-Nikus, but for the once such initial studies, it works. It is okay.
Yeah.
Yeah.
Thank you very much. Thank you.
Thank you.
Ma'am, any questions for him?
No. Thank you.
Thank you.
Okay, thank you, sir, for your presentation. Now, next, I would like to call Sakshi Tiwari to present a study on smart waste management in Delhi NCR using Waste IQNet with dynamic sparse training and model agnostic meta learning.
Hello everyone. I'm not able to share my screen.
Can you try again, ma'am?
Yeah. Is my screen visible?
Yes, ma'am.
Yes. So I'll be presenting my paper on smart waste management in Delhi NCR. So waste is a huge problem throughout the world, but I have specifically done the research for Delhi NCR region because here in Delhi we have a very visible issue for waste management, and as there are accumulating mountains of waste and garbage near around four areas in Delhi, that is Ghaziabad, Bhalaswa, then Okhla, and dairy. So there are four regions which have a huge issue for waste management, and being the capital city, it does not look good to have such issues in such a metropolitan area. So the techniques which have been applied were majorly to make the program and the model which we have prepared for waste management more accurate. So the already done research which we surfed through and studied on majorly had an accuracy of an average accuracy ranging from 94 to 96%. So we tried to tweak it and apply some of the algorithms which we found to be more suitable, and stretched the accuracy to 97.87%. So the problem statement was to classify waste at the to segregate waste at the source, so that so that when the waste requires to be processed, it takes lesser number of steps and more resources to do an intelligent segregation of waste. Then we have also tried to classify it as recyclable or reducible and reusable waste, which we did not find a study to be carried on that topic. And then we have used multiple AI related techniques to achieve this. So how we started? So we started with segregating our data set and accumulating it. For that, we contacted the MCD, the Municipal Corporation of Delhi, and gathered some data from there. We took some of the present data, and then we made our own data set called as Weather. So I'll be explaining these techniques which have been listed here. And this is about the platform which we have used. The data set which we used was quite large. So for that, we have used an M4 chip Apple iMac to process these algorithms and to make our model. So talking about the data set which we prepared, so we prepared a custom data set named as Weather. So Weather, W stands for wet and dry recyclables. So this had majorly two categories, one wet and one dry. So the wet category had two more categories, compostable and spatial disposable, and the dry had recyclable, reducible, and reusable. So each of these, this was the full the structure of our data set. That compostable is having four categories, that is dairy, food, garden, and kitchen. Spatial disposable had eggshells, napkins, non-veg, and tea bags, coffee grounds. Then dry waste has recyclable, reducible, and reusable, and these are the categories present in the respective headings. Then the number of images which we have in each of them are, this is a glimpse of our data set, and these are the number of images which we have for each category. Now to make the model not to be biased for a certain category, we carried out various data cleaning techniques, and we did data augmentation to balance out the number of images in each category. So for that, first of all, to clean the data set, we started with resizing the images and converting all of them to a fixed format of JPEG, and then we converted all of them to RGB color space. And the major technique which we used for data augmentation was smooth ENN. So what smooth ENN does is that it converts the categories which have like very minority number of images, it converts and balances out with the other categories of garbage which we have in our data set, on the basis of, and it also removes the noisy and the blurry images on the basis of the distance it has with similar looking images. So SmoothNN was used for data augmentation. Then after cleaning it, so all the number of images for each category was balanced out to 20,000. So initially we had a data set of around 1,88,000 images, which we augmented and brought to 3,60,000 images with 20,000 images for respective class. So now after data augmentation, we moved to feature extraction. For that, we used DASC, that is dense adaptive self correlation. What it does, it uses this correlation between the features which are extracted using MobileNet v3 large. So this is the model which has been used. So DASC which is used here is inspired by MobileNet v3. So that's why we use the DASC feature. Now, after MobileNet v3, after extracting the features using DASC, we moved on to making our hybrid model, which consists of two models majorly. One which we have used is MobileNet v3 large, which is a CNN inspired model, and it is a pre-trained one on ImageNet dataset. So we used that for extracting features, and also we used MobileNet v3 because it worked well with DASC feature extraction technique. The second model which we used to make our hybrid model was GNN inspired model, that is graph sage model. So we made a solid hybrid model using one CNN and one GNN models. Then after integrating both of them, we also tweaked the same models to do single label classification as well as multi-label classification by just tweaking the activation function which we used. So for single label classification, we used the softmax activation function, and for multi-label, we used sigmoid classification function, because sigmoid activation function works on the basis of probabilities. So on the basis of which category of waste has larger probability, it was able to classify in multiple categories. Then we moved on to after applying our hybrid models, the accuracy was of around 80.56%. So to increase it, we moved to applying layer normalization, just so that it does not has hard limits for any feature label. So we applied layer normalization, post which we applied feature wise attention, which which allots weights to the features according to their importance. So we applied feature wise attention, after which we applied top k mixture of experts. So what does top k does is it just uses the top k most important expert layers which are to be implied to segregate a certain type of waste. Each expert layer works for a certain type of waste, so it uses the top k waste which are applied for any specific type of waste. Then this is the model of our mechanisms which we have used till now. So first of all, we used MobileNet v3 for DSC feature extraction, then a hybrid model of MobileNet v3 and graph sage. Then we applied layer normalization, feature wise attention, and then top k MOE for better extraction of features which to be applied for waste classification. Now the activation functions which we applied, we tried out we tested three activation functions: swish, mesh, and GELU. So GELU was found to work well, and it brought the accuracy from 80.56, which we achieved using only our hybrid model, to 94.44%, especially because GELU used probabilistic methods for activating the non-linear activation in our model. So this is the graph for is the like precision recall curve for a GELU. Then we used DST and MAML. So these were the two most important techniques which we applied. This was applied mainly so that our model can become more generalizable for any new category of waste. Like in the past few years, few years we encountered COVID. So each time any situation can arise which can lead to new categories of waste. So the model or whichever technique we are developing should be generalizable quickly to any new sort of data, any new sort of waste which we encounter. So for that, dynamic sparse training was used. What it does, it sparsely accumulates the type of waste which we have, and increases the distance between similar type of waste, so that it does not create confusion while categorizing a waste into certain classification. And then we used MAML, that is model agnostic meta learning. So what it does, it teaches the model how to learn. Meta learning is learning how to learn. So we used MAML for that. So what it does is, if any new certain category of new waste category is found, so the model is able to train for that new category of waste by just enhancing 1 to 6 instances of the new waste. So using few shot learning and fine tuning, we can achieve this process of meta learning in our waste IQNet. So after applying both DST and MAML, we reached an accuracy of 95.83, and this is the confusion matrix of the same. And post which we applied two more techniques. We tried early stopping and label smoothing. So what does the early stopping do is, it stops to test out and train our model as soon as we encounter that the accuracy of our model is the validation accuracy of our model is dropping. So it stops as soon as we encounter a drop in the validation accuracy. So we applied that as well as label smoothing, and we found out that early stopping helped us to achieve an accuracy of 97.87%. So we went with early stopping, and we did not go for label smoothing, as it led to a drop in the accuracy to 95.04. So with
Excuse me, ma'am.
yes.
Gentle reminder that you've crossed your 10-minute mark.
Sure. So the final techniques which were applied in our waste type unit were with DST and MAML with early stopping was applied finally. So one more thing which we did, just to have predictions based on the semantic distances. So as our data set is built in a 3-level hierarchy, so we applied hierarchical tree laws just to find that semantic distance between the true and the predicted classes is calculated to be minimum of whatever the model is predicting. So this is the taxonomy of the hierarchical tree, and the final results were that we used MobileNet v3 and GraphSage hybrid model, and achieved an accuracy of 80.56. Then FWN Top K Expert was applied, which led to 83.33%. Then layer normalization was applied, then it led to 88.89%. Then GELU was used, which led to 94.44%. Then DST and MAML was applied to 95.04, and finally we used early stopping and achieved an accuracy of 97.87%. So this is the final confusion matrix, and this is the pipeline which I just explained, that how we first cleaned our data and then applied feature extraction using DASC, then the hybrid model, and then our FW and top K MOE, and our activation function DST and MAML, and finally early stopping and hierarchical tree loss. So this was our waste IQ unit, which achieved an accuracy of 97.87%. So thank you. Any questions?
Thank you very much. Thank you very much.
Any questions, sir?
No, thank you very much.
Geeta ma'am, any questions?
No, no. Nice presentation, Sakshi.
Thank you.
Okay, thank you so much for your presentation.
Thank you.
Now we'll be concluding this session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 6 to 7 months. I would request everyone to kindly cooperate with the team of ICTIS 2025. I would like to thank our session chair, Professor Isa Ahmed Abed sir, for chairing the session.
Thank
I'm
you very
sharing a
much.
token of appreciation on behalf of the team, and I would request you to share a few remarks for the presenters today.
Thank you very much. Thank you very much. I am very happy to be here in this conference and share the knowledge with all the presenters and researchers from overseas. Thank you very much.
Thank you, sir. I would also like to thank Professor Geeta Navale ma'am for chairing the session, and I would request you ma'am to share any concluding remarks you may have.
Yeah, sure. Yes, I would like to extend my heartfelt appreciation to all the presenters for their engaging and thought-provoking contributions. Each presentation added significant value and showcased the depth of research and innovation happening in this field. And I would like to thank the organizers for providing such a well-structured platform for knowledge exchange and collaboration. Thank you so much.
Thank you, ma'am. I would
Thank you very
request
much.
everyone to switch on their camera for a quick snapshot of the virtual conference. All right, thank you everyone. Have a